morning students. So in previous class we discussed regarding introduction part related to cables. So what are the different types of cables and what are the analysis things we have to be known to solve the problems like maximum tensile forces, minimum tensile forces, and also if the cable rests on particular some types of supports, how we have to compute the forces. So these are the things we have already studied in previous class. So in this particular class I am going to take one particular problem related to suspension bridge. Okay, now let us move on to the problem. So in this particular problem, a suspension bridge of 120 meter span. So suspension bridge, having A, B at ends. So having a span of 120 meter. So this particular span is given as 120 meters and it's having a central dip of 12 meters. So it's 120 meters central point, exactly at 60. It's having a central dip of 12 meters. And supports a UDL of 15 kilonewton per meter over entire span. So over entire span, matlab up to 120 meters on the next slide, so supports a UDL of 15 kilonewton per meter. So I am taking this as point C, it's a central dip. So it will become 60 meters. And this will become another 60 meters. Clear? At support A and B are having external support reactions VA, VB, and the horizontal reactions also develop ends. Because of symmetry, the H values are same. So H. So this is the given thing. Depending on data, we constructed a suspension bridge. Now, what is asking to determine? So this is the given thing. This is the given. What we have to evaluate? We have to evaluate. The first is minimum and maximum tension in a cable. It's asking to determine what is the maximum force developed in the suspension cable, as well as what is the minimum force developed in the suspension cable. We have to determine T max and T minimum in A, and in B what is asking? Size of the cable. What is the size? What is the diameter of the cable? If the permissible stress in the material, in the cable material is given as sigma permissible is given as 200 MPa, 200 Newton per mm square is given as 200 MPa. Stress is given, we have to determine D dash in second. And third, it's asking to determine length of cable. That is S. I know L, I know dip, is asking to determine S. And also forces in tower. So there are two towers. We have to assume some particular tower supports. Either it may be pulley or it may be saddle. Depending on the type of support, what are the forces in towers? We have to go to determine in D. In tower. These are the four things he is asking to evaluate. This is a very, very important problem. There are several times asking in VTU examinations. So first we will move on one by one. T max and T minimum. For the evaluation of T max and T minimum, first we have to evaluate external support reactions. So to determine external support reactions, that is VA, VB and H, we have to apply equations of statics. That is sigma Fy equals 0. The general sign convention is all upward forces are positive and downward forces are negative. So plus VA minus UDL. Convert UDL into point load. It will become 15 into 120 and plus VB equals 0. We are getting VA plus VB equals 1800. Say equation number 1. Say equation number 1. Next you take moment at A equals 0. If you take moment at A equals 0, general sign convention adopt, clockwise positive, anti-clockwise negative. If you are going to consider moment at A, VA and H both are 0. This H is also 0 because acts in a same line of action. Then this 15 over a span of 120, 15 into 120 rotating in clockwise direction. Therefore 15 into 120 by 2. It's the moment. This is the force into this is the moment, distance. So next this VB rotating in reverse counterclockwise direction minus VB into span. Distance is 120 equals 0. So if you solve this, you are getting 900 kilonewton. Now substitute this in equation number 1. We are getting VA is also 900 kilonewton. Now we got VA and VB value. Next, how to evaluate H? It's very simple. Take a moment at crown C, dip. So if you take sigma MC equals 0, take right hand side RHS. For RHS, general sign convention, clockwise positive, anti-clockwise negative. If you take this only right side part for a moment, we are getting H into dip. The dip is 12 meters and this VB is rotating in counterclockwise direction. Matlab minus VB into perpendicular distance is 60. With respect to this point, this UDL is rotating in clockwise. Plus 15 into 60 into 60 by 2. So this is clockwise, this is anti-clockwise and this is clockwise. This clockwise plus anti-clockwise minus clockwise plus. This is general sign convention. Here also we adopted. Now I know VB value is 900. Clear? Substitute the value of VB here. You are getting H value. Please substitute the VB value and compute H. What is H?
2250 kilonewton.
2250 kilonewton. 2250 kilonewton. Using these external support reactions, we can easily compute T max and T minimum. We know the equation. T max equals square root of V square plus H square. Here VA equal VB equal V is 900 kilonewton. Therefore square root of 900 square plus 2250 square. How much? T max?
2423.32.
2423.32 kilonewton. And T minimum, which is equal to H, horizontal force, it is nothing but 2250 kilonewton. So we evaluated T max as well as T minimum. So this concludes the first part of A, computation of T max and computation of T minimum. Maximum tension developed in a cable, minimum tension developed in a cable. T max is 2423, T minimum is 2250. Next we move on to size of the cable. Size of the cable B. We all know that from the mechanics of materials, the basic definition of stress. What is stress? Load by area or force by area. So here sigma of the material permissible is given as 200 Newton per mm square. And also force. For force, you have to take T max. T max. And area, I am assuming a circular area. Then pi d dash square by 4. Don't take pi d square by 4. If you here in this particular problem, d is referred as dip. So if you are considering this d, then it will become confusion. So that's why I am taking d dash. When d dash is the diameter of the cable and d is the dip of the cable. Okay. So now I know stress is 200. I know T max. T max is 2423. 2423.32 kilonewton. Convert it into Newton. Because this is in MPa, Newton per mm square. Here also it's in kilonewton. Convert it into Newton. Divided by pi d dash square by 4. Complete d dash. You are taking millimeter. What is the value of d dash?
124.2 mm.
124.2 millimeters. This is the diameter required for the analysis. It is the diameter required for the analysis. So our second part is also over. Now what is the third? In third point, we have to compute length of the cable. Here we know that there are two cases. In previous class also I discussed regarding supports at same level. What is the equation of S to compute length of the cable? If the supports are at different level, we are having different equation. So for length at same level, length supports at same level, length of supports at same level. What is the equation?
S is equal to
S equals
L plus
8
by 3 into d square by L.
D square by L. See, where D is dip, clear? D is dip is given as 12 meters. Now, S equal L is span. What's the span? 120. 120 plus 8 by 3 into dip. Dip is 12. 12 square divided by length 120. You just solve this, you are getting S value. What is S value?
123.2 meters.
123.2
meters.
meters. So we got length also. So the third evaluation is also over. Now I want to determine the forces in tower. For this case, I will give assume pulley support with anchored cable as 25 degree. Assume pulley and take theta as 25 degree and height of the tower equals 20 meter. Height of the tower H equals 20 meter. Evaluate moment at bottom of tower. So this is the thing I am asking to compute forces in tower. So I am assuming only one case in this particular problem, that is pulley case. For this case, say pulley. For this case, I have already given some certain things. So height of the tower is also given, that is 20 meter, and also this theta A is given as 25 degree. So I want to compute force TA. Forces in tower means I want to compute moment at bottom as well as TA. What is the value of TA? What is the force developed in the anchor cable? That is also one of the aim of this particular TA. So I have to compute TA. I know T. This is T. T value I know, T max, square root of E square plus H square. That is 2423.32. to 3.32 kilonewton. I want to compute theta s. Theta s equals tan inverse of V by H. I know VA equal VB, that is 900. Therefore, tan inverse of 900 divided by H value is 2250. So, what is the value?
21.8 degree.
21.8 degree. I got this value as 21.8 degree. Now, resolve this and resolve this. It's very easy. This is TA cos 25, vertical is TA sin 25, and this is T sin 21.8, and this is T cos 21.8. Just resolve the thing. Now, for pulley, you take sigma Fx, sum of horizontal forces. Sum of horizontal forces. What happens? Minus TA cos 25 plus T cos 21.8 equals 0. I want TA. I know T value, that is 2423.31 cos 21.8 divided by cos 25. I am getting the value. What is the anchor cable force? How much?
2423.32.
2423.32 kilonewton. So I got TA. I got TA value. Clear? Next. What is sum of vertical forces? What is sum of vertical forces? Sum of vertical forces is simple. TA sin 25 plus T sin 21.8. You just substitute TA and T value, you are getting sum of vertical forces. How much? 1924.0 kilonewton. Now the thing is, I want moment. For moment, I require sum of horizontal forces. So compute sum of horizontal forces. I know TA value. That is TA cos 25 plus T cos 21. Therefore, moment at bottom equals sum of horizontal forces. Net horizontal force, right? Net horizontal force into distance is 20. So, what is net horizontal force? How much?
53.74
53.74. How we are getting it? Simple. I know TA value, substitute here, that is minus 2423.32 into cos 25 plus 2423 T value I know into cos 21. Substitute here, you are getting this value 53.74 into 20. So you are getting moment. How much? 1074.8 kilonewton meter. This is the moment. So this is the simple problem. You just concentrate here one more time. The all data are given. I have just taken all data. So he is asking to evaluate first one, minimum and maximum tension. Second, diameter is given stress. Third one, length of cable and also forces interval. And here he will specify the case. In this case I am assuming pulley. So for pulley case I have given theta anchor cable value and H value. I have computed moment as well as anchored force, tensile force. So in first I have determined external support reactions and I have evaluated T max and T minimum. In second I have taken basic sum, stress is force by area, and I know stress value. I have evaluated D dash, where D dash is the diameter. In next I have computed length of cable. I know the equation where the supports are same level S equal L plus 8 by 3 D square by L, where D is dip. Where D is dip. These are the some important things you have to remember. Now just substitute the values. I got S. And lastly, this is the D part, forces in tower. Forces in tower. For this, I have assumed the pulley. I have assumed the pulley support, and I have evaluated the force in anchor cable, and I have evaluated the moment at the bottom of the tower. So this is regarding very important problem, and these are the simple steps. I hope all of you are getting the things. Thank you.